So these are sample questions from the test. All the questions on the test will look exactly like this. And like I said, with the proofs, there are 9 proofs here, and there'll be 3 or 4 on your test, but they'll be from the paper. So you don't need to study proofs outside of this. They're right here. And then these are the same proofs that were on your homework. So if you don't have full credit on your homework yet, after we're done with this, you'll have the answers to fill into the homework from the last couple days. So we'll have time to do that. I am going to go through a little bit fast just so we make sure we have time to do some homework. So just be mindful of that. Okay, so number 1, it says planes J and K intersect at line M. So the rectangles here are the planes. So plane J and K, they do intersect at line M here. It says state the postulate that can be used to show each statement is true. So 2 planes intersect at a line, and that's why that's true. So 2 planes intersect at a line. Number 2, it says choose the property that justifies the following statement. It says if x equals 2 and x plus y equals 3, then 2 plus y equals 3. So what they're doing is they're taking this and they're substituting it out for x to get this equation. So they're using substitution. Number 3, choose a property that justifies this statement. Measure angle A equals measure angle A. That is a reflexive property when it just equals itself. Number 4, choose a property that justifies this statement. GH is congruent to FD, then FD is congruent to GH. That is symmetric property. And the other property to know that comes up a lot is transitive property. Study transitive property. And remember, transitive property is like, okay, if A equals B and B equals C, then A must equal C, like that. So that's the one like if Kyla is the same height as Camilla and Camilla is the same height as Lucia, then Kyla and Lucia must be the same height. Okay, and then number 5, it brings in some math. There's just a couple ones with like number math. Here it says measure of angle 1 is 3x plus 15. So looking at this picture, 3x plus 15 here. Measure of angle 2, 6x plus 3, and it says find x. Well, in this picture, measure of angle 1 equals measure of angle 2 because they're vertical angles. And vertical angles are equal. So to solve for x, we can do 3x plus 15 equals 6x plus 3. And then solve for x. So I'm going to subtract 3x from both sides. Then subtract 3. I get 12 equals 3x. Then divide this by 3, divide this by 3, and I get x equals 4. And that's my answer there. Okay, the next one, if measure of angle ABC is 34 degrees, find CBD. Let's see, ABC, 34 degrees. It says find the measure of CBD, so this right here. It shows this little square right here. That means that these two angles are complementary and they make a 90-degree angle. So to find this missing one, we can do 90 minus 34. It comes out to, I believe, 56. Yeah, 56 degrees. And that is our answer. Okay, so now we're going to start getting into the proofs. I'm going to go kind of quickly through this. Again, I want to just maximize the time. So, are you ready? Okay, so the first thing you're going to do when you get to proofs is fill in the given and the proof statement just to maximize points on this. So given always goes in this first line. So it tells us that angle 1 is congruent to angle 3. Reason, given. So we already got those points correct. And then the proof statement goes in the last line. So if they don't have that filled in, just fill in angle 1 is congruent to angle 2, like that. So we already got over 50% of this right just by doing that. Now I'm going to look at what they actually gave me in terms of the picture. It says 1 is equal to 3. Cool. Then this next statement says that angle 3 is equal to angle 2. Okay, they are equal because they're vertical angles, so that would be vertical angle theorem. And you do have the answer bank down here. I can cross it out as I go too. And then last but not least, like if 1 equals 3 and 3 equals 2, that means 1 and 2 can be equal. So that would be transitive property. Okay, next. If you can abbreviate as you do it just to make it faster, that is great. Okay, then this one here, first things first, plug the given in here. I realize this given is pretty long, so we'll just like go like that. So looking at what the given says, it says AB is equal to DE. It also says B is the midpoint of this segment and E is the midpoint of this segment. And it wants us to prove that BC is congruent to EF. So first things first, I'm going to plug this in the last line too. BC is congruent to EF because I can get that right as well. Okay, then for here it says AB is equal to DE. They told us they were congruent, now they're saying they're equal. That's definition of congruence. If they're congruent, then they're equal in length. Then it says definition of midpoint. Well, they told us that B is the midpoint of AC. And definition of midpoint, if B is the midpoint of AC, then AB is equal to BC. And if E is the midpoint of this segment, DE is equal to EF because of definition of midpoint. Then in the next step, since AB is equal to DE, they like plug this into this, or they plug it in to get this statement. So that would be substitution. Substitution. And again, they substitute again to get this. Like if EF equals DE, then they plug this in for DE to get this. So substitution again. And then to go from BC equals EF to BC is congruent, they use definition of congruence. That symbol means congruent. Are you guys keeping up with me? We're good. Okay. Go ahead and start the next one. First things first, plug in your given and your proof statement. So let's see, prove goes down here. EC is congruent to AC. And then the given goes right here. And then AB congruent to CD. And BC congruent to DE. You have it. And I'm going to mark on here too what AB is equal to CD and BC is equal to DE. Okay, then it says definition of congruence. So if these are congruent, then they're equal in length. So it's looking for AB equals CD, BC equal in length to DE is what they're looking for there. Remember, you have your answer bank, you're dragging and dropping. Then from here, we're looking at how they come up with this. When we look at the picture, AB plus BC, AB plus BC equals AC. Cool, that's segment addition. And the same with CD plus DE equals CE. That is segment addition. So here, segment addition postulate. Cross that out. Next, they start using substitution. Since AB equals CD, they plug in CD for this. And since BC equals DE, they plug in DE for this. And that's how they get this. So they use substitution. And for the next one, if this equals EC, so to get this here, since these both equal EC and AC, they're using either transitive or substitution, whatever is in the answer bank, and substitution it is. And then last but not least, they're going from equal to congruent. That's definition of congruence. Okay, when you're ready, just flip it over. Okay, do two separate. Yeah, I'll leave. Okay. Then on the back, here, like I said, I'm going to go through this as quick as I can. And these are all the answers to the homework too. So given, you drag and drop that here. And it already says given right there. It's saying C is a midpoint of this segment AE and C is a midpoint of BD. It also says AE is congruent to BD. So this whole segment is congruent to this. Then it says AC is equal to CE. That's because of definition of midpoint, and it says that this is equal to this. That would be definition of midpoint. Then it says, I know the copy's not great, AE equals BD. Well, they said it was congruent in the given, and now they're saying it is equal. So that's definition of congruence. Then it says segment addition postulate. That is the concept that AC plus CE equals the whole segment AE, and BC plus CD equals the whole segment BD. That is segment addition. Then, since AE and BD, AE and BD are equal, they use substitution to say that this is equal to this. So they use substitution. And then they use substitution again here. So since AC is equal to CE, they like plug this into the other one to get AC here. So substitution again. I know, not the best copy. You'll see it better on your homework. And then simplify, they combine like terms, say 2 ACs equals 2 CDs. Then they use division property to divide both sides by 2 to get AC equals CD. And then if they're equal, then they're congruent. That's definition of congruence. While I have this on the screen so that way I can keep moving, I'm just going to kind of slide this over and work over here. Okay, so first things first, plug in your given. PA equals LN. And then also plug in the proof statement so you can get those points. PL equals AN. Proof statement always goes last. Okay, then let's see what they're saying. They're saying PL plus LA equals PA. That's segment addition postulate. Segment addition postulate. Then it says that LA plus AN equals LN. That is segment addition postulate. Okay, so in the given it says PA equals LN. So then they substitute this for each of those to get this statement, substitution. And then last but not least, to go from here to here, they're subtracting LA from both sides. So that is subtraction property. Okay, quickly get that down, and I'm going to slide down her. Okay, if you need me to go back up at the end, I can. Okay, so then here we'll put the given. I'm just going to draw a circle around it and like draw an arrow. You would just drag and drop here. Reason given. The proof statement here, angle 2 and angle 3 are supplementary. Cool. So that's proof statement. It just drags and drops it there. Okay, then next, angle 1 and 2 are supplementary. Well, I look at the picture and they form a linear pair. So that's why they are supplementary. So that would be linear pair postulate. Then it says definition of supplementary angles. Well, if they're supplementary, then they equal 180. So angle 1 plus angle 2 equals 180. Definition of supplementary angles. Then here it says measure of angle 1 equals measure of angle 3. Well, in the given it said they were congruent, so therefore their measure is equal. That's definition of congruence. Then for this, since 1 equals 3, they just took this and substituted it in for measure angle 1. So that is substitution to get this. And then since these two add to 180, they're supplementary. So that would be definition of supplementary angles. Supplementary angles. Okay, and moving over here, our given right here, they already filled it in for us. Proof statement's already filled in, so that's good there. So it says 1 and 3 are complementary, 2 and 3 are complementary. It says measure angle 1 plus measure angle 3 equals 90, and 2 plus 3 equals 90. That would be definition of complementary angles. So then what happens is since they both equal 90, they just set these equal to each other here. So that would be substitution. The next statement says reflexive property, which may throw you off, so I would just look at the answer bank, and here is clearly reflexive property, so I'll just drag and drop that here. Then from there, what they did was they subtracted measure of angle 3 from both sides. Subtract measure angle 3 to get this, so that would be subtraction property. Then they go from measure of angle 1 equals measure of angle 2 to their congruent. That's definition of congruence. Almost done. Okay, then this one, of course, given first and foremost, given. Then it says definition of congruent segments. This is a congruent statement, so then we can say that they're equal. Okay, J equals MJ. Then they make this, so they have the LK equals NM, and then they add KJ to one side and MJ to the other side. Since they're equal, they're adding the same value to both sides, so that would be addition property. Then it says segment addition postulate, so that would be this here, where I could write it all out, but essentially like Lj equals Jk plus Kl, and so Nj equals Nm plus Mj. Then it says Lj equals Nj. They're using substitution. And then if it's equal, then it's congruent. So definition of congruence. Denise, it's not you, it's the copy. It's hard to see. I saw you adjust your glasses, but it's the copy, it's not your eyes, don't worry. Does anybody do that with their AirPods? Like if their AirPod dies like on one side and they're like, oh my gosh, I can't hear. And then you realize it's just your AirPod. But you have a mini heart attack. Okay, number 3. This one, given BD bisects angle ABC. So BD bisects ABC. So that means angle 1 is equal to angle 2. So that would be definition of angle bisector. Then it says, okay, 1 is equal to 3. I look at their relationship, their vertical angles, so that's where they are equal. Vertical angle theorem. And then if 1 is equal to 2 and 1 is equal to 3, then 2 and 3 must be equal. It's congruent to angle 3. So that would be transitive property. Okay, and that is all. So grab the laptops, log in really quick, and then go to your homeworks and get your homework points if you didn't get full credit already. This little one.